Assalamualaikum warahmatullahi wabarakatuh. So, our topic for today is relations. In this video, we are going to discuss about what is relation, which is the introduction, then types of relation, then the application of relation, and the last one, the conclusion of the relation. This is our group members that consists of 6 members. So, first of all, what is relation? Relation is defined as relationship between two different sets of information. For example, we are given two sets containing two different values, then a relation defined when it connects the value of the first set with the value in the second set.
So, next is types of relation. We have empty, reflexive, symmetric, transitive, equivalent, universal, identity, and inverse relation. Okay, firstly, empty relation. A relation R on a set A is called empty if the set A is an empty set. Any relation where no element of set A is not related to the element of set B, then it is called an empty relation. So, this is the example you can see. Next, reflexive relation. A relation R on a set A is called reflexive if A is subset R, hold for every element A subset A. If set A that have AB, then R, AA, BB is reflexive relation. So, this is the example you can see. Then, symmetric relation. A relation R on a set A is called symmetric if BA subset R hold when AB subset R. The relation R that have AB, BA is a reflexive relation on AB. So, this is the example. Then, transitive relation. A relation R on a set A is called transitive if AB subset R and BC subset R. Then, AC subset R for all ABC subset to A. So, this is the example.
Equivalent relation. Equivalent relation is like a special kind of friendship between elements in a set. To understand it better, let's break down its 3 properties. First, reflexive. This is like everyone being their own friend. In the set, each element is related to itself. For example, if you are in the set, you are friends with yourself. Second properties, symmetric. Is like mutual friendship. If element A is friends with element B, then B is also friends with A. Third property is transitive. This is like a chain of friends. If A is friends with B and B is friends with C, then A is also friends with C. Okay, next relation is universal. Universal relation is like saying everyone knows everyone else in 2 groups. If we have 2 groups, A and B, every person in group A knows every person in group B. More simpler explanation, everyone in one group knows everyone in another group, covering all possible pairings between the 2 groups. To explain the concept of an identity relation simply, an identity relation is a special kind of relation where every element in a set is paired with itself. This means each element is related to itself and no other elements. Okay, the last relation is inverse relation. Inverse relation is a way to connect elements of one set with elements of another set. The inverse of a relation is found by swapping each pair of elements in the relation. If we have a relation R that connects elements from set X to set Y, the inverse relation R will connect elements from set Y back to set X. Okay, that's all.
So, we move to the application of relations.
Understanding relations is vital in discrete maths and computer science. This involves reflexive, symmetric, and transitive relations, which are also equivalence relations, and provide the foundations needed before any function can be defined at all. The understanding of these ideas is also necessary for database theory, formal verification methods, as well as algorithm designs aimed at coming up with relevant solutions to real-life problems.
Application of relations, propositional logic. Propositional logic, also known as Boolean logic, deals with propositions that can be either true or false. It uses logical operators to form complex expressions from simpler ones. Moving on to logical operators, there are 5 operators, which are AND, OR, NOT, implication, and also biconditional. And moving on to example, so here we provide a logical equivalence. Logical equivalence is a fundamental concept in propositional logic where two statements are equivalent if they always have the same truth value. So one common application is simplifying logical expressions. And then if you can see at the left of this slide, the other problem provide, which is to simplify the expression A and in bracket A implications of B. So the solution is to firstly express implication in terms of and, or, and not. So A implication of B is equivalent to not A or B. So the expression becomes A and in bracket not A or B. And then we distribute and over or. And after that, we simplify using basic logical identities, which is A and not A is always false, which is contradiction. And then A and B A remains as it is. So the expression simplifies to A and B. And that's all.
So for the conclusions, in discrete mathematics and computer science, one of the basic things to know about are relations. Modeling data connections in terms of relation which are reflexive, symmetric, transitive, or equivalence can be used for the purpose. To show functions, one can use relation like this. For example, these terms play a crucial role in database theory. They also find applications in formal verification and algorithm design. This is how we get systems that work properly and with great speed. Understanding these relationships enable us to develop robust solutions to actual life problems, which in turn promote systematic and logical problem-solving skills. The exploration of relationships form a base for addressing intricate issues in a rational and organized way, which consequently facilitate the formulation of efficient algorithms whose reliability can be checked, considering their applicability to computer science and software engineering. For anyone who wants to build a career in such professions, it is important to have an excellent grasp of methods dealing with connections and their use. This base provides support for academic and career development while additionally contributing to the development of sustainable and impactful technology solutions.